Hello, 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 hello.
Hello. How's it going? So today I'm gonna um so basically yesterday I wanted to do something and I found out that the thing that I wanted to work with was broken because yeah, you should never do like electronic project while drunk because you'll end up connecting something to something else that you're not supposed to connect together. So, yeah. Um, Today I want to design a PCB that basically, uh, en- um, basically contains, not contains, I don't know how to say it, but basically is about the the thing that I was making, a device that's not a stream deck, but it's a sort of stream deck. And while browsing the internet, I found something really interesting, and it's called like OBS WebSockets, and basically allows me to control OBS over WebSockets, and I can use it with Node.js, like uh, what I was doing yesterday, uh, to get like information about what scene I have loaded in OBS and stuff like that. But first of all, I wanted to look at the board that I want to design, and for the time being, I want to use like I don't know. I want 8 buttons, so that's simple enough to do. That's not a big uh, problem or something. So yeah, let me start drawing the schematic and we'll see. I'm using Eagle because it's cool, and that's uh, the only ECAD that I know how to use. And also I think that I need to load the libraries though. Okay, let me do update all, or wait, actually open library manager. Ooh, ooh, where's the ooh? Oh, wait, why don't you use? Yeah, I had to like draw the microcontroller that I'm using in Eagle so that I can build a PCB around it. And I will be using the ESP-12F because that's the one inside of the Wemos D1 Mini that I have been using like the other day and stuff like that. So yeah, so and also I need 8 buttons. Let me see if I can find them by saying switch. Where are you? No, it's it's not. Is it push button? Push button. No. 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 Why do you have? Wait a minute. Let me just search for Omron. I don't know. Omron switch. Okay, nice. Here's the ones that I want. Okay. So let me add them. 1, 2, 3, 4, and you can just select them. Ctrl C, Ctrl V, and I have 8 buttons. And I want to connect these 8 buttons to 8 of the GPIOs here. And also I will be adding a pull-up resistor because wait, that's not a smart idea to add everything at the same time. I'll show why. And here I have the switch, and I will be adding a ground symbol to connect one side of the button to ground, and also I want a capacitor across the contacts to avoid bouncing. And bouncing is a phenomenon that occurs in when two metal contacts come together. For example, in a switch, when you press the switch, you might experience like unexpected behaviors, like by pressing one time the buttons, the microcontroller or other devices might detect like multiple push presses, and that's why the metal contacts actually oscillate and make multiple contacts in time. And by adding a capacitor across the contacts of the button, you will basically filter this high frequency noise that for us is it's not really detectable, but for example, for an Arduino that runs at 16 megahertz, like this noise might be like well-defined pulses, and this will mess with our hardware. There's a simple way to add this feature in code, but it's simple enough to use a capacitor to remove these unwanted behavior. So let me add a capacitor. Let's see, CUS, and I want to work with SMD components where it's possible, because I want my board to be as low profile as possible, and I cannot find SMDs. Let me actually filter for SMDs, and I want a 0805 components because they are simple enough to solder, but they are not too big. But also you can use 1206, and they're actually simpler to solder because they are actually bigger. But the capacitors that I have are 0805, so I will be using 0805s. And maybe bigger pads are something good. So we'll be adding the capacitor here, and as I said, I want a pull-up resistor. And a pull-up resistor is a resistor that connects this push button to VCC, in this case 3.3 volts. And let me add the resistor, and also I want the SMDs. And for the resistors, I think I will be using 1206 because I have 1206 resistors. And RUS 1206. Okay. And let me add the plus 3.3 volts. Let me search for supply plus 3 V3. Okay. And for good measure, let me add another one here for the microcontroller. Okay, so now let's connect the components, and it's simple enough. Okay, no, Ctrl-V. Okay, and ooh, Jesus. Yep. Is it too fucking loud? Okay. Okay, so now let's tidy it up a little bit. Ooh. And yeah, no, or yes, maybe. Okay, so now let's give some values so that I don't forget values. It should be like something like 10k ohms here. Also, let me move the labels here. And okay. And this capacitor, I found that 100 microfarad is good enough. So 100 nanofarad. Ooh. Let me move the. It was good here. Okay, 100 nanofarad, and here. Nope. And here I will be connecting I will be using a label to connect the actual pins, the actual net here to the GPIOs here, because it's much better to not like connect stuff with wires like these, for example. Yeah, using labels is much more tidier. So now I can Control C and I can Control V. 1, 2, 3, 4. So, and now I can do this, and now let's name those nets. And by naming the net, we'll be naming the connection. So I don't know, B1 for button 1, B2, B3, B4. I'm sure that there's a more efficient way of doing this, but yeah, B7 and here I have my buttons. Move group. Let's move it like there. And now we can okay, pin breakout. Okay, so let's do like B1, 4 grid units, I guess. GPIU, like, let's say 2, 4, 5, 9, I don't know, 6, 7, B8. And also I want to change the size of these things, because it's kind of annoying that they overlap. I didn't use GPIO 0, I don't know why. I don't feel like using it. And yeah, let's connect these to these. What I wanted also to do was like having like, ooh, what the fuck did I do? My eagle is such a pain to use. Ooh, where's my okay. What I wanted to have was like maybe some LEDs for like illumination here, and maybe some other features that like what scene am I in, or something like that, I don't know. And basically I want to have like an LED for switch 1, switch 2, switch 3, switch 4, switch 5, and so on. And basically yeah, controlling them through the microcontroller, but I have like 3 pins available only, so I might be able to use a shift register to control 8 LEDs with 3 pins, and that might be the smartest of ideas. And also I might need to move those somewhere. Yeah, maybe I should have. Yeah, let me actually redo this connection. See here, and also the labels should be 05. Nice. Okay, net B1 auto increment 6 grid lines I want. B1, ooh, yeah, Jesus. B2, B3, B4, B5, B7, B8. And let me shift register. I can use the SN74595, which is a pretty standard shift register that it's used in plenty of things. So we have basically 8 outputs here, Q, A, B, C, and D, and also we have QH and QH, and this thing, like, I don't know what's it called in English, but yeah, this is basically the same output as QH, and it's used to like daisy chain those things, and it's really cool. So here we have five control inputs. Let's say this is output enable, register clock, shift register clear, shift register clock. Wait, is it register? Yes, it's register clock. And this is the serial data that we are going to output through the microcontroller. Output enable, we don't really care actually, because output enable just enables these buffers here at the end. And basically if you put these pin to ground, because the line above a digital signal means negated, so it's not active high, it's active low. So that means that if you put like a low level voltage, so 0 volts, it will be active. So if you enable this line here, you will have either 0 or 1 depending on the serial data here. But if this line is disabled, you will have a what's called an high impedance connection. That means that whatever is connected here will see like a open circuit from this thing here. And this is useful, for example, if you want to control like the same lines, for example like QA with 2 different things, and you don't want like these shift register to interfere with whatever it's connected like to these other lines. And serial clear, we don't really care, because we can just shift zeros and clear the shift registers, the shift register. And register clock is basically whenever the let me actually go in order. So you have serial clock, serial here. You, for example, let's say you put a 1 in the serial pin here, and this goes here, and this is a D flip-flop. And basically a D flip-flop is kind of like I don't know, it's kind of like something whatever you put in this D pin here goes out. And you can think like of this whole chain, because this is connected to this thing here, like as D flip-flops in series that you can like you shift like a 1 here, and the 1 is stored in this thing here. Then if you like send a signal to serial clock here, it will shift this 1 that you put here to this other one, and you can like put another 1 here, and it will be stored here. And if you toggle the serial clock here another time, the original 1 that you put here will go here, and so on. That's why it's called the shift register, because you shift whatever you put in the serial line here to all these registers here, these D flip flops here, and finally, when you have shifted like 8 bits into these shift memory, let's call it, and a shift register, you can toggle the register clock that will basically take the bits that you put into these D flip-flops into these other RS latches. Those are called RS latches, and yeah, and they will be present. The bits that you put into those D flip-flops will be presented at the output. So we can use 3 pins to control 8 things. But actually you can daisy chain as many as you want, but I bet there's like an upper limit to the amount of shift registers that you can daisy chain. So let's say virtually infinite you can control virtually infinite things with only 3 pins, and that's awesome. So yeah, that's a actually perfect thing to have in here, to have in what the fuck. So let's I have the 595 in the through hole package. I guess we want to use them. So yeah, why not? So let's add the 595s. 595. Also, what's the difference between US and EU? That the EU is thicker. Okay, so this is not the one that I want to use. Oh, I have checked the SMD's one. I don't want the SMD in this case. Ooh, that's a confusing. Okay, so nice. Yeah, we can add. Ooh, wait a minute. We're dealing with 3.3 volts. Is this rated for 3.3 volts? I hope so. Okay, let me see. Absolute maximum ratings. Recommending operating conditions. Minimum 2.2 volts. Nominal 5 volts. Max 6 volts. Okay, so we can definitely use 3.3 volts. Okay. The minimum for okay, for 2 volts the minimum is 1.5. For 4.5 is 3.5, 3.15. I wonder if I can do that. I hope so. Maybe we should test it. Actually. That's not a bad idea. Yeah. Let me set up the thing. But actually, since I will be powering this from USB, yeah, I guess we don't need to test it because we will be actually stepping down the 5 volts of the USB to 3.3 volts. So let me see. Linear linear regulators, 3.3 volts. Is it uh, um um mm, mm, what's the no, it's 7803. Let me see if that's a thing. No. Okay, 3.3 volts. Linear regulator. Let me. Actually, let's go to RS. Yeah, it will be in Italian. But that's not the point. Okay. Yeah, I will be searching in Italian. Linear. Okay. 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 Let's say. Okay. 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 Oh, Jesus Christ. Output voltage. 3.3 volts. Or 3,3. Okay. Let's apply the filters. And package. I want SMD. Because I don't want a big package sticking out. Or maybe, yeah, 100 milliamps. No, that's not enough. That's definitely not enough. 500 milliamps. That's. Wait a minute. ASP12F power consumption. 50 and 400 milliamps depending on different. No, okay. 500 milliamps. It might be too low. I want like a bigger headroom for. Okay. Okay, 500, 600, 800, 600 milliamps. Let's see what the search terms. Okay. Yeah, but I want something that I can buy on Amazon. I don't want to buy from RS. Jesus. Let me. Amazon. Jesus. Can I do like. Okay, let me search. Always in Italian. Lineare 3.3 volt. 100 milliamps. That's not. I want. Or. Okay. 800 milliamps. Yeah, but I don't want modules. Wait a minute. Let me see what they use here. Because I have the board here, and I want to see what they use. it's too small to read. Let me actually try and zoom with the phone. Man, I wish I had a magnifying glass. What is K820? For A20. For A20 regulator. Let me see. Oh, that's the. Wait a minute. Yeah, 4820. Is that the? Yeah, but that's not a 3.3 volts. 3 volts, 3.6, 3.3, 150 milliamps. Oh. Yep. I think we need to. Ooh. AMS 1117. AMS 1117. AMS 1117. Oh, that's expensive. Adjust. Oh, it's a variable one. Oh. I guess we need to use a variable one then. Man, that sucks. Yeah, but can I get them? AMS 1117. Oh, that's real nice. Yeah, but I want. Can I fucking. Yeah, but 10 pieces for 70 cents a piece? I don't want 70. I want 10. Yeah, I guess we can. We're taking 10. Nice. So now I need the data sheet to design. Okay, so first of all, let's see if AMS 1117. Okay, nice. Ground input and output? What? No, don't tell me. Really? Are you fucking kidding me? No. Do I need to draw my own palle? Okay, so we are drawing our own schematic. Let me save this. And ESP port. No. What's the name? Stream thing. Yes, I have no idea on how to call it. Stream thing. Okay, so now let's open this other one. Go to libraries. Let's go to my miscellaneous stuff that I use for work and for my own thingy. And let's where's the data sheet? I need the AMS 1117 data sheet. I need the data sheet. And advanced monolithic systems. Okay, it's a SOT223, I guess. Oh, it's 1 amp. Nice. Doesn't it say the fucking package? But I guess it's SOT223. Do I have an SOT223 here? No, yes. I have SOT23. So we're going to draw an SOT223. Yep, create a new footprint. And we need the specifications for there's not the footprint, no? So SOT223 footprint dimensions. Okay. Nice. I love this. Reflow soldering, wave soldering. We're not doing any of this. Let's open the image. Wow, this is so bad. In millimeters, that's what I want. Let me put this on my other screen. And let's pick wave soldering because it has bigger pads. So it's 1.7 by 1.4 the pads. Okay, so 1.7 millimeters by 1.4 millimeters, and it's like this. So it's 1, 2, and 3, and another one that is 4 width. It's 4 millimeters by 1.7 millimeters. It's kind of like this. Okay. So now we need to figure out the distance between centers of the pins, and if you see here, it's basically 1.4 plus 0.9 plus 1.4. It's the distance between here and here, and if we add these to 0.9 and divide by 2, we will have the distance between centers, because it doesn't fucking specify it. So let me do the math. It's okay. It's 1.4 plus 0.9 times 2. Oh, divided by 2. Okay. So it's 2.3 millimeters between centers. So what I can do is go to eagle, set the grid to 2.3 millimeters, 2.3, and do okay, stop, and do something like this. And this is properties. This goes to 0, 0. This goes to x 2.3, 0, and this goes to minus 2.3, 0, and this one goes to 4 millimeters and 0. Yep, that's the, yeah, no, it's not 4 millimeters, is what, 4.8? Is it 4.8? Man, what the fuck? I should have picked like a better picture. Oh, yeah, of course. Yeah. Why not use these instead of the fucking low res one? Jesus Christ. Okay. Yeah, it's the thing is 1.7 times 2 plus 4.8 divided by 2, which is 4.1 millimeters between centers. Is it though? Is it? It's not. What did I do wrong? 1.7 times 2 plus 4.8. Oh, okay. Plus 4.8 again divided by 2. And now it's more like it. It's 6.5. The distance between centers. So it's not 4, but it's 6.5. This should be more like it. Yeah. Yep. Yeah. And now that we have our really cool design, I like to move it, the center, to be more centered with the thingy. And now I want the actual datasheet to look at the package, the epoxy thingy dimensions, and it's 3.71. Wow, there's a lot of tolerance. I guess that's fine. Okay, it's 1.46, 3.71 by 6.71. Well, I guess we can use 6.30. That's actually better. So it's 6.30. Yeah. So let me draw in T place. Let me draw like a properties. Okay. No. Let me actually. No, because fuck it. Let me remove them. Oh jeez. Because in Eagle you have to set like coordinates. You cannot set like, hey, I want this thing to be this long. No, you have to set coordinates. And I have to mess with, okay, it's 6.9, but I want it to be 6.3. And also this should be 3.3 and 3.3. Apply. And this should be 6.3. And now I can move this. Let me actually use the finest option. Yeah, that's good enough. That's good enough. So yep, let me okay, default. Okay, now let's write some text, and in Eagle you can say like that symbol and name, and you can make it show up the name of the part that you're putting in the design. So let's put it somewhere like here, I guess, and that's good enough. I can say Control S to save, and now I want a symbol called AMS1117. Yep, create a symbol. And also though, Control S, maybe I want to rename the pads to like 1, 2, 3, and 4. But let me actually pull up the how do they call them in the datasheet so that there's no confusion. We call it 1, 2, and 3, and we will call these 4. Nice. Ooh. Okay. Where is he? Okay. 1, 2, 3, and 4. One, 2, 3, and 4. Control S, and now we can go back to this. Let me have it on my other screen. Ooh. I need to oil my my mic stand. Yep. Okay. In, out, and adjust. Okay. It's just a square, like it's not a square, it's a rectangle. Okay. Yeah. And let's add 3 pins. In, out, and adjust. Ooh. Ooh. So this is in, out. No, this is adjust. Adjust. And this is out. And now we can maybe make it a little bit slimmer. No, it's fine. It's good enough. I don't care. Name should be in the names layer. And also this should be like 07. Yeah, I think that's good. And also the pins here have a property called visible, which basically off the shelf, when you make a actual device, basically you connect the symbol with the footprint. If you have like this setting here to both, it will show here, it will show in, and on here it will show the name of the pad, which in this case, for example, it will be 1, 2, and 3, and something else, I guess, because there's also the tab, and I don't remember what's the tab. So one is adjust. 2 is the tab not connected. Tab is output. I don't know, but I guess we will leave it unconnected. So yeah, that's good enough. We will use it only for what's it? For support, mechanical support. AMS 1117. Yep, create this new device. And add part. AMS. Okay. Prefix. It's an IC. So new, add the local package. Add this here. Okay, connect. One is ground adjust, which is good. 2 is V out, and 3 is V in. Okay. Okay. It's good enough. Also, I want to adjust the symbol a little bit. I want to move it to be more centered because it's bothering me. Also, wish that the distance here would be like less than this, but I actually don't know if it's possible to change this. I don't know. I've been using Eagle for like 3 or 4 years, but I never figured out. Yep. Okay. So Control S, and we should be done actually. Yep, I think so. So we will be adding. Let me find the library. Where's Miss? Okay, and now we have our own symbol in Eagle. Pretty cool. Okay, nice. And it's ugly as fuck, to be honest. But yeah, good enough. A trick that you can use when dealing with like circuits that you don't know, or yeah, just look at the shit. Most of the times they will use like, they will give you like a pre-made schematic Hello, Analog. You've been like 1 hour late. What the fuck? SMH. You're banned from the server. Banned forever. I will ban you forever. Oh, Andre, porco dio, ma tutti mo siete arrivati, mannaggia Cristo. Oh, 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 oh. Yo. Okay, so I'm designing because I'm a qualified electronics designer. Not really though. So I've been doing a schematic that does a thing, and I explained to. No, sto scherzando, Andre. Per piacere, per piacere. Okay, so I've been explaining to like someone, I don't know, that basically I have, yeah, I don't know what I have, but basically I have been doing the designing, and this is are like buttons to use in with the thing. And yesterday I discovered that not every pin on the ESP12F can do pull-up resistors, and I don't know why, and it has been bothering me. So I decided to use external pull-up resistors. So yeah, I designed the input stages to have a resistor as a pull-up resistor, and to have a debouncing capacitor. And to explain what everything is, for a pull-up resistor is, as the name kinda suggests, it basically pulls a line up, and pulling a line up means that the line is defaulting to like the high voltage, and so basically instead of like being unconnected, or basically instead of having it like floating, it is connected to in this instance to 3.3 volts, and when you press the button, this line will be connected directly to ground, and that means that it's gonna be low to ground at 0 volts. And also I don't know why it didn't put the junction symbol here. I don't know, it's bothering me. Let me actually. Okay, nice. And the debouncing capacitor, its job is to filter high frequency noise coming from oscillations inside of the push buttons, because when you press a button, you feel like you're doing only one push, but in reality, hello Simon. Oh, yo Simon, if you want, you you can basically have everything I'm doing, and you can start streaming, because that's really good thing actually. I think if you started streaming, yeah, don't do it though, because that's our job. That's the Magpie Pirates job. You're stealing our job. You gave us a job and you took it away. Yeah, do whatever. So yeah, don't steal our job. So yeah, the debouncing capacitor basically removes these high frequency noise coming from oscillations inside of the button. It's oscillating like, I don't know, 10 kilohertz. I don't know, I never measured it. It would be nice actually to measure this to show why it's a good idea, why it's a problem um, in actual products or DIY projects. Because the first time that I encountered this problem, I didn't really understand how it worked, but yeah, it's there, it's always there, except when you're dealing with high voltages and relays, because relays are impedances and they deal with frequencies and do a lot of stuff. So, but yeah. And then I have a ESP 12F microcontroller here, and I have these three general purpose impedance. Impedance. How do you pronounce it? Impedance? Impedance. Impedenza. In Italiano, in Italian is impedenza, and impedenza is made of resistenza and reattanza, and in English is impedance, reactance, and resistance. Yo, I'm smart. Yeah, I know. Impenenza, impotenza. Imparenza, i parenti sono come i denti, più sono stretti e più fanno male. Am I right, Andrei? Oppure i parenti sono come i serpenti. My grandma used to like say shit like that, like relatives are like teeth. The tighter they are, the more they hurt, or something like that. I don't know, but in Italian is so much funnier. Più sono stretti più fanno male, because parenti stretti is like close relatives, but denti stretti means like, I don't know, crammed teeth. I don't know. I don't say impedance, impedance. Wait, it's impedance, not impedance. Yo, Simon, check out our our merch shop. Yo, yeah, let's check. Okay, Simon the Magpie merch, I guess. I actually don't know what the fuck. Is it this? Wow, really good design. Wow, let's look at the design. Oh my god. Oh yeah, yeah, really nice. Oh my god. Yeah, please go. Wow. But also, let me gotta scroll down for the new ones. What kind of What kind of bullshit is that? Wow, edgy, so quirky, so random. Oh my god. Yeah, really nice. Ooh, really nice. Really nice. Oh, this is cool. Go to bottom. This is cool. This is legit cool. I like it. It reminds me of fractals. It's really cool. Actually, I think we should have like a Mandelbrot t-shirt in our abstract space painting. In the eye. Solid white magpie. Die cut stickers. Yeah, I could use some stickers. Nice. Yeah, really nice actually. Yeah, okay, nice. Yeah, go ahead and go outside with this, especially if you live in an English-speaking country. Nice. Really cool, really cool. I love it. Is this a cat, by the way? Or is abstractly... Or is it an abstract cat? Also... no. Nice. Wait a minute. Wait a minute. I need to do a thing. Wait a minute. Okay, let me do a thing. I don't know actually if I can do this because of same origin policy, but I wanted to replace the image with like some funny shit. But also, yeah, consume. Consume? What the fuck? Are these edible? Nice. If those are edibles? Are you sure? I've been having like problems with shit like that. No, only feedback now. Okay, feedback. Those are really cool. Really nice. I love them. And yeah, the drunk neighbor shirt is one of the best. And you can say like, yo, this is like a famous person, and then it's Dakato. Consume equals buy. What? Yeah. Yeah, I just consumed a TV. Isn't that cool? No. You're gonna get poisoned. Don't do that. Dakato. Sexy man. Ooh, whoa. Lost in translation. What the fuck? Spreadshirt. What the fuck? Yeah, about the shop. We should move the shop to our site and move the warehouses in Analog Weapons house. Yeah, really nice. Go buy the merch, please. Also, I should make like an OBS overlay that just says buy the merch and uh slides the merch. Check out now latest design. I think that it will take a while to uh to to load the new designs, unless they, because of propagation, I don't know, maybe. Yo. Yo, I'm buying it. Yo, I'm buying it. Yo. Yo, I love this Arial text. Color standard. Yo, 10 plus. Yo, 700. What? I cannot do like more than one digit. Okay, am I spending $1 million? Add to cart. What? Yo, I love this. 4,000 euros. You can lower price to $1. €1. I love this. Let's see if I can like overflow the thing. Max 999. That's not a thing. Let's see if the site is good. I don't think that it works like this. €11,000. Is this like a permanent thing? Also, no, I don't want 7 million. I guess I'm buying it only because there's TDC written on it. Yeah, I did type in value. Wait, let me check my size. It's L. Just like description, yeah. Product details. Add to cart. No, Jesus. Well, I'm not putting my info on stream because I'm not a fucking degenerate. Well, I guess I'm buying it after the stream. But I'm definitely buying it because I want it. Okay, so let's okay, so let's go back to the regular scheduled content. So so now I made a 3.3 regulator thingy here. That's oh Jesus. Okay, so as I was saying, on the datasheet, usually you can find like hints on how to design your circuit around the stuff, and you have also like stuff that says how to calculate values for regulators and also stuff like that. And yeah, we will be using it. But also, what I wanted to say is that I wanted to have like an LED that shows what scene am I in, and since I ran out of general purpose input outputs, I can use a shift register, like a 595, and I will be using the through hole one because since I want a low profile board, I want to use mainly SMD components, but since I want it to be as cheap as possible, I want to use stuff that I already have. So serial clock, serial SCL, serial clear, serial. Okay, G is enable. So output enable should be to ground. Okay, let me do. Okay, also I need to invoke. Where's the invoke? No, yeah, replace. No, where is invoke? Invoke power. Yeah, I don't know why the fuck do they do that. So let me go to supply, and let me add a 5-volt rail. I will be using the 5-volt from the USB. And ground. Yeah, I know that I cannot copy it. Jesus. Okay. Ooh. Oh. No, I want this style. And I want this. And maybe, and I say maybe, I want it to go like this and like this. Yeah, I don't know why they fucking make this shit like this. It's ugly and I cannot stand it. But yeah. Jesus Christ, you're so discreet. Yeah, they saw your password. Okay, so this is serial clock, and register clock. So we'll be naming them, and let me name SCK, and RCK. I also explained how a shift register works, but y'all are late and I won't be going again. Okay, serial clear is active low, so it should be to ground, right? Wait a minute. 595 data sheet. Okay. Where's the okay? Output enable. I want it zero clear is high. Here is always low. What? Okay. I think that's what I want. I want output enable to be ground. Wait, is there a pin description or something? Okay. Output enable and yeah, Jesus Christ, what a description. I want a pin specifications, application and typical application, detailed design. No. Okay. Serial clear should be always high, because otherwise it will reset. And output enable should be always low, otherwise it won't output the actual data. So I guess G goes to ground and this goes to 5 volts. This goes to 5 volts. 5 volts. Yep. Okay. And then these goes to the various LEDs that I want. So I want LED 1, auto increment, 6 grids. So it should be LED 1, LED. Ooh, I didn't select. Okay, LED 1, auto increment, 6. Okay, LED 1, 2, 3, 4, 5, 6, 7, 8. Analog, fuck you. Okay. And also, I think I need to buy SMD LEDs. If shit. Yeah, that's a thing. That's a thing that I need to do. Haha. That's sucky wacky. I guess that's fine though. Okay. So we'll be connecting serial. Okay, these 3 C T T T T to labels and name serial clock and register clock, SCK and register clock. And we have no other pin available. Don't you like about 100 LEDs? Fuck you. No, I don't need 100 LEDs. What do you mean? Yeah, I know this track sucks. Jesus Christ. Yeah, fuck you. I need to spend like 35 euros to get a 5-meter LED strip of WS2812B LEDs to remake from scratch the LED matrix because I burned it. But this is another project because continuity is not something that we love. We don't want continuity between our stuff. So, okay, so we will be working on the regulator now, and the regulator needs some resistive network to work, and I don't actually know. Um. Okay, so solid tantalum. No, fuck you. I don't know. Where's the formula? Parasitic load regulation. Yeah. Ripple rejection. Give me a fucking formula and that's it. RP times what's RP? Yeah, it's not multiple, but the ratio. What? Connector 1 to case or 2 to load. What? What? Yeah, thank you. Hey nerds, is there any way to split the guitar signal so that one part can go into pedal that is sensitive to impedance and one can go wherever? Yeah. So I guess you can have a splitter, a buffered splitter, or a like one output of the splitter is buffered and the other one is straight from the input signal, and making a buffer is actually pretty simple, but you you can do it pretty simple, but how sensitive are we talking about? uh hmm because if it's really sensitive, well, in theory you should like match the impedances, but yeah, that's something that I don't know. Well, you should like have the output impedance of your splitter be equal to the input impedance of the fuzz factory, so you have the maximum power transfer. That's something that I remember about this shit, because we only did one lesson about this, and we never used it in a lab situation. We only did like stuff with NE 555s, LM741s, and that's it. Or you can buy a product that does it for you, like out of the box. Fuck you. No, that won't be a DI. That would be a something other thing. Oh, okay. B out is Bref plus I. Okay. 1.25 volt reference voltage between the output and the adjust terminal. So yes, but it's very small and constant, small error, and can usually be ignored. So yeah, the output voltage formula is this thing here. Knowing Vref, Vout, and fixing one of the two resistors, we can easily calculate R1. And let's see. So let's how do I go about this? Um, is that like a online spreadsheet thingy? Yeah, but I need an account, so let me bring the big guns here. Alright, Google Sheets. Google. Okay. So we have Vref, which is 1.25. Okay. We have V out, which is 3.3 volts. And we have, like, let's say R1, which, I don't know, 10k. Also, got it. Shit. This means 3.3. Okay. Okay. So I have too many tabs going on. So let me write it down on a piece of paper so that I don't have. Okay, so V out is equal to V ref times 1 plus R2 divided by R1. So let me use paint to. Okay, so we have VO is equal to VR times 1 plus R2 divided by R1. So we can divide everything by VR, and we have VR. And why it changed the dimension, I don't know. VR. So now we have this thing here. Did they fix R1? Yeah. So now we can subtract 1 from both sides, and we have R2 divided by R1 is VO divided by VR minus 1. And if we multiply both sides by R1, we get R2. And that's our formula. R2, R1 is equal to this. So R2 is equal to VO divided by VR minus 1 times R1. I think. Analog, you're so funny. Okay. So R2 will be equal to VO divided by VR. Minus 1 times R1. What? Divide parameter 2 express number values, but bref is a text. Oh, yeah. Because that's the Italian version, I think. Wait. What am I check? Oh, yeah, fuck you. No. It's not A2, but it's A3. And now I need to use the points. Because in Italy, we don't use points to divide between decimals. What? What did I... B4? B3? A3. No, it's B3. It's B2. It's... Okay, 16 kiloohms. Let me see. Nope. That's not. Let me see. 4.7 kiloohms. 77. No, let's say 5.6 kiloohms. Oh, it's do I have 56 kiloohms? Yes, I do. Okay. 56, 91. The closest I have is 100 kiloohms. So, if I say actual here and say V out is equal to Vref times 1 plus whatever I put here divided by R1, which I input. So if R2 is equal to 100 kiloohms, 3.48, 3.5, yeah, it's good enough. 56 kiloohms and 100 kiloohms. That's good enough, I think. But I also have 68, so let's see. 68. Oh, nope. Let's go back to 47 kiloohms and 77. If I do 68 kiloohms, 68, it's 3.05. No. If I do 33 kiloohms, it's 54, which is really close to 56. Yes, we got it. 33 and 56. Nice. That's really good. That's actually really good. Because you have to work with standard values and resistor values follow these standards. E resistor values, images, yeah, follow these thing. There are 1, 2, 3, 4, but I bet there are more standards. uh, so you have those are the the numbers that are multiplied by a multiplier. Like this could be 1 home, 10 home, 100 homes, but even whatever. So like in E12 you have 100 multiplied by any other constant that yeah, for example, uh, 100, 1000. So you can have every single um, multiplication of 100, 120, 150, 180, and yeah, you have like, for example, E12, since it's 10% tolerance, it's like one of the cheapest by Andre. E20 and E96 is like the most expensive one because you have 1% tolerance, but also you can get like smaller tolerances. So yeah, I went with basically E12. That's the kit that I bought. Also, I think that you can get like E6 resistors. Images. E6. I don't know. Yeah, but you can get it. So what did we say? 33 and 56. So before I forget, so I guess we're using through-hole components for this because that's what I have. Yeah, that's fucking awful, but yeah, that's we're gonna mix shit together in hope that it works. So resistor, where's RUS? I like to use 0277. Yeah, let's use these for to be sure. And what did we say? R1 is 33 kiloohms, which means that we R1 is the upper one. Okay, so R1 is 33 kiloohms. So where's the value? 33k, and this is 56k, and this should go here, here. Why did you change? And this goes to ground. This goes to ground. Okay, nice. We can move these up to be a little bit more cool. And also these suggests to add like 10 microfarads and 22 microfarads here for stability. So Let me see if we got them in house. I think that I need to buy them. So that's fine. So we won't do that because I'm not bothering with doing that because I'm cheap as fuck. Okay, so now we need LEDs. So I was thinking about I don't know, something like for retro illumination and something for something else. Let me think. Okay, so we can. Well, first of all, let me put like LED, and I want to go with SMDs, and I want. No, I want 1206 if possible. I mean the package, the 1206 package. Let me see. 1206. That's what I want. And I want also SMD resistors. But it really I don't know, I want like blue LEDs or something. What do you think? Blue LEDs, red LEDs, green LEDs, yellow LEDs. I mean, red LEDs are kinda nice. Or blue LEDs actually. Or something. Also blue. Yeah, blue LEDs in 1206 packages. So let me see. Let me pull up Amazon. I want the Italian version. Jesus Christ, no, I want Amazon.it. Jesus. 1206 LED blue. 50. I don't want 50. But I want I kind of want a kit actually. So LED kit. And I want like prime. Those are fucking trimmers. I want LEDs. Those are resistors, LEDs. I want LEDs. Do I fucking need to go to RS to buy this kind of shit? Man, I don't really want to use RS. It's fucking a pain in the ass to use RS. Do we really fucking SMD LED kit? Let's I guess I can steal them from work. So but I really want to have like a kit. Yeah, still. Some the LED kit. Do we really not have the fucking thingy SMD LED kit? I don't know, 1206 LED, because 100 pieces. Yeah, and there are 5 colors, so it's 20 LEDs per color. That's kind of. Oh, no, 1206, dude. Those are 0603, 0805, 5050. Oh, and those are 1210. Jesus, I really want those, but I also want like a kit. Well, I guess blue is 3.2 volts. So if we have if we have 5 volts minus 3.2 volts divided by, I don't know, 10 milliamps, we have a resistor, a resistive value of 5 minus 3.2, which divided by 0.001, which is 1 milliamp, so 180, so like 220 ohms should be fine. 220 ohms, it's fine. So we have SMD LEDs now, and resistors, and the 220 ohms that I have at work are either 1206 or 0805, so I guess I'm using resistors. 0805 resistor, 0805 IUS 0805, and these, okay, this connects to ground, okay, and guess. Okay, so we need Control C, Control V, 2, Control C, Control V, 4, Control C, Control V. And now we can make the pin, so should be LED 1, auto increment, grid Unix 6, LED 1, 2, 3, 4, 5, 6, 7, Jesus, oh, 7, 8, okay. So now let me group stuff together. I don't know, info LED, and maybe the size should be a little bit bigger, and those are the buttons. And yeah, buttons. Move group. And this is the shift register to control the info LEDs. Shift register. Okay. Okay, this is the microcontroller, and I don't know if, because I'm sure that there's a way to program the ESP12F over the Wi-Fi, but I also need to flash the thing before to be able to do that. So I will need breakout pins for RxD and TXD, remembering that this is a 3.3 volt thingamajiggy odd part, headers. I don't want SMDs, I want pads. No. I want two fucking. Yep. That's. Why do I get the fucking date? Steve Vai collab. I don't know what collab is. Let me check. noise rock. Also, do I need the enable thingy here? And do I need to... Okay. Yeah, maybe for now let's focus on the software side of things, because that's kind, because I'm unsure about some stuff here, like I don't know. I need to check the schematics of the WeMOS D1 thingy, and yeah. So let me close a bunch of this stuff, and let's see where. Okay, so yesterday this is I was messing with this thing that basically takes the get requests from the microcontroller and converts them to keystrokes. But I have on my OBS, let me pull up OBS, WebSocket server settings, and I can, well, OBS basically now is running a WebSocket server, and I can access the OBS API basically through WebSockets. Ooh, nice. Ooh. And why Windows 10 has this useless feature that if you do this minimizes the fucking thingy. So yeah, and let me see. Okay, what was the name? OBS WebSocket remote control OBS. No, that was what was this? Okay, for developers, JavaScript Web OBS WebSocket JS. That's the thing. In Node, const OBS WebSocket is required. Address is optional. Defaults to localhost with a port of. Okay, nice. Super secret. Okay, nice. Sending requests. All requests support to the following two syntax options. Where, okay, so basically using promises or callbacks. Support requests, connect and disconnect. Okay, nice. What is defined in the OBS WebSocket plugin? So let me see. Protocol maybe. The fucking reference for this kind of things is bullshit. Authentication, table content system sense. Okay, events, right? Is that the thing? Request name. Request name. Switch scenes. Scenes changed. Scene collection changed. Scene. What? What? Recording, replay buffer, other, general, heartbeat, sources. Can I get like a current scene? Oh, requests. Okay. Events. Okay, no. Requests. Get version, get auth. Authenticate, set heartbeat, set file name formatting. I don't know what that is. Media control, play, pause, media, restart media, stop media, next media, previous media. Okay, sources, get media source list, get toggle, get audio active, get source settings, get text GDI plus, set browser source properties. Can I get the current? Because that's what I mainly. Oh, get current scene. Okay, nice. So let's see. What the fuck did I do? Get current scene. Ordered list. Of the current scene source items. Okay, so let's get crafty. So I need to do npm install OBS WebSocket JS save. Is it the name of the package though? Wait a minute. Okay, I'm back. Okay. So yeah, that was the name of the thing. Yep. OBS WebSocket JS. Okay. So usage const OBS socket. Okay, nice. Now let's open Node and let's say const. Okay, so now let's say is it a constructor or something? I can close eagle definitely. Okay, let me have this thing opened on the side. Okay, OBS. Okay, so const OBS equals new OBS web socket, and now I can say OBS connect dot connect. Nice, thank you. And we are connected. So now if I say OBS dot OBS dot I lost the reference. Jesus. Okay, requests, scenes. Where's the scenes? Scenes, get current scene, name and sources ordered list. Request fields, no specified parameters. Okay, nice. So if I say OBS dot send get current scene dot then, since it's a promise, console.log, I want to log.catch, console.error. Okay, so we have the name of the current scene. Nice. Yeah, too easy, man. You can fucking Google anything, and you'll be almost sure that someone already did it. Yeah, and we have the sources, like radio. It's a browser source, and also the volume of the source. And since you have basically full access of the internals of the OBS API, basically, you can actually edit those things, and that's pretty cool. That's pretty cool because now imagine that I have my stream deck thingy soldered, and it's really nice and it's pretty cool. And well, I guess the only thing that you need to do here is have like a setting parameter file, JSON file, that you specify, like button 1 does this, button 2 does this, and so on. And for example, if I press the button, and I can actually like switch scenes by looking at the config file, retrieving the name of the scene that I want to bind to that button, and after that I can just tell the ESP thing to do the thing, to turn on the LED that says look, scene, the scene binded to for example button 3 is on, so the LED lights up. And also you can change the volume with this thing. Ooh, yeah, I'm stupid. I lighted the filter of my cigarette. Jesus Christ. I'm too excited about this OBS thing, because once you have like once you have a way to communicate with OBS through JavaScript or Node.js, actually, you can basically do everything. I wanted to look at OBS plugins, like homemade ones, but I don't have like a real experience with C++, and what I wanted to do is have an OBS plugin that basically works as a web server, or like a WebSocket server that does exactly this and talks with the OBS API, but at the same time has a WebSocket communication with the ESP. But that requires me to learn about how to do that shit in C++, so that's not really the easiest thing to do for me. But that's the smartest thing, because you just launch OBS and connect your device through an outlet, and it will automatically connect to the thing. And assuming that you have something like MDNS installed, you can actually have like a name instead of an IP that could change depending on if you're streaming from home or from somewhere else. Because, yeah. So yeah, I also looked at OBS scripts, but that was required me to either learn Python and all its libraries that deal with web servers and shit like that, and I don't know how to do that, and or learn Lua or LUA, I don't know how to pronounce it, and I don't know what the fuck that is, so I don't know. I think that it's, I don't know, for me it's more complicated to learn Python than just look at references to how to use libraries for JavaScript, modules for Node.js. Yeah, never used it, so I don't know. Once you learn a programming language enough to be uh, like comfortable with it, so yeah, I don't know. Yeah, but the thing is that OBS doesn't allow me to write Node.js applications to run within OBS. They only allow Python 3.6, and I am installed 3.8. I don't know why they don't support 3.8. But yeah. So, um, so let me look more at the WebSocket here reference to see what we can do actually. So also events, let me see. Events are broadcast by the server to each connected. Oh yes, I love this, because then I can have the ESP. Yeah, Simon, I wanted to actually explore VST plugins programming, but I don't know. Yeah, I should make a stream called DDC Learns C++ in 3 hours. And all this shit like unions and templates and I don't know. Yeah, C++ is... Yeah, but I come from approaching C and C++ from Arduino. So Arduino is pretty basic, and it doesn't require you for basic usage to know much about C++. You basically need to know types and basic types, and also Arduino defines its own types like byte and shit like that. Yeah, the actual C++ name is different. It's not byte, but yeah. or at least I think. I don't really know. But yeah, so coming from Arduino stuff, it's kind of a mystery. And I tried to look uh, at more into C++ programming for real, and yeah, I didn't get really far because I'm lazy as fuck. And the majority of the stuff that I want to do, I can easily do it from within Node.js. Yeah. And Node and JavaScript is kinda really awesome because you can do a bunch of stuff that if you want to do it like in C or in C++, it becomes like a mess. Like even defining an array that doesn't, yeah, you don't need to define like a size of the array. Like I don't even know how to do it in C++ or in C. So yeah. But yeah, that's not the point. So how do I listen for events? Receiving events. That's OBS on event name data. Okay, nice. Okay, so oopsie daisy. Okay, so we can say const OBS WebSocket is equal to require OBS WebSocket JS, and we can say const OBS is equal to require. It's not equal to require, it's equal to OBS WebSocket. And yeah, okay, upset port 3000, this server that listens to port 3000 for the ESP. To make a Node.js BST engine. Yeah, why not? But I guess everything comes back to C++. Yes, V8 is written in C++. So that's a added layer of complexity that in like digital signal processing might not be a good thing. So if I want to okay, so so if I say like obs.on, oh, it's okay, yeah, why the fuck? Okay, add the catch handler to every return promise. Okay, no. Okay, no. Different words, promise, spoiler. Okay. Where's the? Okay. Let me have it here, and let me have the chat. Hey chat. Hello chat. An event message will contain at least the following base fields: update type, stream timecode, record timecode. Okay, so events. Type defs. What the fuck is that? CYCX alignment. The point of the. Okay. Ooh. You get also positions of. Okay. So. I bet like the stream deck uses this kind of shit. Events scene, switch scenes changed. What's the difference between switch scenes, a scene change? This event is not fired when the scenes are reordered. What? What's the difference then? Scene collect. Oh, okay. Scene collection list changed. Transitions. Okay. On the switch scenes, I guess. List of scenes items in the new scene. Okay, so let me try. And on switch scenes. Switch scenes. Okay. On switch scenes, and how do I? Okay, receiving events. It's data. Okay, data. And then I need an error handler. Okay. Data. Console.log data and obs.on error console.error Control S. Now if I do here obs.disconnect. Okay, and if I do Control C, also I need to connect obs.connect. Why am I using semicolons? Fuck semicolons. Okay, so now if I use node index, okay, I cannot invoke without new. Oh, Jesus Christ. Why am I stupid? Okay, Control C. Okay, it's connected. And now if I switch scenes, we should get a console log here in OBS. So nice. I switched scenes from screen cap to intro, and then I switched back to screen cap. Nice, really nice. So yeah, okay. Oh, update type. Okay, wait. Scene name, stream time code. Okay. Okay, here are the sources. Okay, the source names. Okay. Yeah. It's a bummer that doesn't give you when those lines of characters showed up in that one part of the screen. For people who don't code, that part was exciting. Yeah, it's really exciting, actually. Ooh, what did it do? Yep. Whenever you see something that you expect, it's really exciting. But most of the times it doesn't. Okay, so now I should be able to send like scene switch packets to switch the scenes. Okay, so let me actually have a look at the events that we have. Switch scenes, scene change. Okay, transition. Okay, switch transition. Whenever it transitions, the active transition has been changed. What? Okay. I don't think that's really exciting. Oh. Okay. Switch scenes. Scene. Profiles. No streaming. Stream starting. Wait a minute. No, that's kind of tempting actually. That's kind of tempting. Because we can make the bot listen to people's stream OBS and ping the shit out of people. Yeah. Yep. Okay. We even have like transport layer security. So yeah, we actually could do that. But we should ask people to install software that I wrote. That's not something that you want to do, especially if you don't, if you're like in nobody. Okay, so yeah, great idea. Install a malware. Let's log people's data, especially with Node.js that has like full control over file systems and shit like that. And you can easily write a shitty like malware with it. Okay, source created, destroyed. I don't care about these. Media playing, media paused, stopped, scene items, source, order changed, scene item added, studio mode switched. Okay, no. Request general, get version, get auth required, set heartbeat, set file name formatting, get stats, get video info. Open projector. What's that? Open projector? Where's open projector? Open a projector window or create a projector on a monitor. What's a projector? I don't get it. Play pause media. Play pause media. What's play pause? Is it no, but it's a browser. Set text free type 2 properties. Add filter to source. Move source filter. Set audio monitor type. Get audio. Oh, you can do everything from these. Jesus. Get sources list. Yep. Profiles, set current recording. Replay buffer. Get replay buffer. What's replay buffer actually? Why the fuck? Replay buffer. Get replay. Okay. Get the status of the OBS. I don't know what's the OBS replace. Scene collections. List scene collections. Scene items. Get scene item list. Okay. Scenes. Set current scene. Okay. Set current scene is what we. Get scene list. Create scene. Oh, get scene list. Okay. Yeah. Since I will be the only one using this, I don't care about making a GUI that allows you to set everything. I can just use a JSON file and that's it. If OBS was running remotely, you could make a whole web client with this. yeah, let's fucking buy a VPS with GPU and shit like that. let's bu- let's buy like a cluster of Raspberry Pis and put it somewhere. Okay, is the radio died? Has the radio died? Man, I wish we gave like people directions on how to uh, how loud their track should be, because man, it looks like I always have to turn up or turn down the volume. Also, be right back. Fingerman, hello Dan. If you ever listen to this, I appreciate you. So please, let's make like a law in the Magpie Pirates that if you don't make your um, track loud enough or quiet enough for release, you get arrested. That's a really good law. Also, analog. Going back to buying VPS with like graphical support or like a graphic interface or something that it's not headless. I think that that's not a bad idea, because then we can run OBS on it, connect through it with this kind of shit, and yeah, you're guessing right. But if Simon if Simon plugs our merch, we can buy it. Or I guess we could like, I don't know. Yes, sugar daddy. Hello, Simon daddy. Please. No. Well, if we want to experiment with it, I guess we can. Oh shit, oh shit, oh shit, oh shit. Abort, abort, abort. Ban, kick. Hide from chat, please, please. Okay, if we want to experiment with it, I guess we can run OBS from one of our computers and have the other one use it from remote. The only thing that you need to be sure about is that your ISP doesn't block traffic on certain ports on both exit and both in and out, because the ISP that I have at my parents' house blocks a lot of shit, and also they also have like a VPN kind of shit. I don't know. Well, it's for testing purposes, you know? So yeah, better stream quality to host. Yeah, better stream quality equals sending your stream data directly to us, not through Discord. So and through our RTMP server, you can relay their data to our stuff. And well, the only way to mix streams, or well, I guess if we want to mix streams, because I was thinking that the best way is to have one single central unit that controls every stream, and I was thinking about doing this through an OBS, like running somewhere and receiving the streams from other people, and you then set some sources that receive those RTMP streams, and you can then do whatever, and you can add transitions, overlays, and do whatever you want. And that's the end goal here, having like a centralized a centralized OBS that streams to YouTube, and that you can stream to, like, you know, I know that you want to have like switch streams through like without mixing a re-encoding, I know, but I think that's better. Yeah, good VPS with bandwidth. You make that exact thing as part of our money. I know. And yeah. Yeah, but also, yeah. Yeah, we need better bandwidth. But also, since Magpie Fest is kind of like a thing, a one event per year usually, we can like for 1 month we can update our plan. But again, if we want to run OBS remotely, we need a VPS that it's not headless. So and that's not the case for our current setup, because OBS doesn't run headless. Or actually it does, but you need to build it from source. Yeah, but also OBS uses a lot of OpenGL, and I guess mainly for filters and shit like that. So it requires GPU. So we need a VPS with a GPU plan, because otherwise we won't do shit with it. Okay. So yeah, let's keep the brainstorming through to another. Okay, so config.json. What I want to do with this JSON file is basically I don't know. Let's say maybe an array of objects or something like that, like because I want to be able to both like my main use for the stream deck thingy is switch scenes and mute the microphone and do some other shit. So for now, let's assume that every button switches. Let's first program the button thingy. So an array. So the first button will be the first element of the array. So name. Okay, name should be like okay, so I don't know, like scene. Okay, so in my usual OBS, I have scene intro. Then I have scene full cam and scene screen cap. Control S. So I know that the first button will be scene, the intro, second button full cam, third button screen cap. Okay, so in index.js, let's require the config file. So const config is equal to require com./config.json, Control S, and config now has scene strings. So if the bit is high, wait a minute. Okay, so if the bit is pressed, do I really need? Okay, wait a minute. No, okay. This end point here is good. It's good enough. So if bit here if the button is pressed, if bit, okay, so let action is equal to config I, which is an object called with scene. So I want to differentiate between like action switch scene or something like that. Like I want like to have like action switch scene. Actually I can do this. Wait. Yep. Okay. I got it. We got set current scene, request field scene name. So if I in the config in the action thing I set the name of the request. So instead of naming it action, I say request set current scene, is it set current scene? Okay. Control C, Control V, Control V. Okay. Okay, so let action is config I. So obs dot send action, oh, action dot request, and what's the name of the property? Scene name. Scene name. And scene name is action dot scene. Control S. Okay. Now, if I config I is okay. So bit must be equal to 0. Okay. So if I now do Control C, okay. Okay, it disconnects automatically. Nice. Get, okay. So if I need a way to convert from binary to decimal. So if I do node index again, and I go into localhost 3000, and I say combo is equal to 254, it should switch to intro. Let's see. Oh, yeah. Wait. Yeah. The first element was disabled. So I need to use another one. So it's 253. 253 should switch to screen cap, to full cam. Nice. And if I say 254, it should switch to screen cap again. Let's see. No, 254. No, it's 250. Wait, it's scene 2, so it's 0 B 1 2 3 4 5 6 7 8. So this is 1 2 4 8. So this 255, 254. This is 255 minus 2. This is 251. In order to switch to intro, I guess. No, screen cap. Nice. Okay. See? It works. Really nice. And we don't need robot.js anymore. And we still need this thing. Okay. Action.request. Okay. And now in the Yeah, I love this. This is fire. This is fire. But I guess that I actually don't want an array, but I want an object with uh, like one, no, zero, zero, but okay, zero, one, and two, because then I can also skip, like if I want the eighth button, I can just do this instead of having to fill empty shit. And yep, it's really nice. Control S. I really love it. I'm not gonna lie. And it's real good. Okay. So, what time is it? It's kinda late in the night. It's so late in the night. So, thank you everyone for watching. And I think I'm gonna go to sleepy. To sleepy. And my plan for the next stream that I will be doing is actually making the board, like at least the layout of the board. And the plan for that is to make it single-sided so that I can easily make it at home. And if, as we say in Italy, if God wants, se Dio vuole, we could make a stream where I actually make the board, and that's gonna get edited in some kind of pod thingy. That's really cool, so that people can look at the highlights for how to make a PCB at home. And I don't know, maybe I will bust out the photo thingy that I made, but I don't know, because yeah, I need photosensitive PCBs that I don't have. I only have bare copper PCBs at home that I think that are large enough for these kind of board, because I think that it's gonna get kinda big. And also I need to buy the microcontrollers, because I want to have everything on board soldered permanently. And yeah, that's gonna be really interesting, because I'm gonna be soldering shit. And the next stream is gonna be me soldering the thing, and and yeah, and testing it. Yep. This is shipping out on a lot of stuff to spend a lot of more money to get the materials to do something else. Also, I'm curious, what's a Stream Deck price? What's the price of a Stream Deck? Yeah, fuck's sake. Come on, dude. Come on. Plus, what? No. 54 year. Oh. Okay. No, 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 no. I want Amazon.it. Stream Deck. Yeah, but come on, dude. Come on, 149 euros. That's the cheap one. Yeah, I guess that's the cheap one. But you get this nice dot matrix stuff, and also you can bind like other stuff. Yeah, 149 euros, and it's actually reasonable enough for the manufacturing, the feature that you get, like the icons. You need I couldn't find. Yeah, no, it's not basically just some buttons. It's dot matrix color screens here, dot matrix displays, and also plastic here. And does it work over the network too? Oh, it's LCD, it's not. Con un tocco potete cambiare scena. Okay. Yeah, and also you get an app thingy. Yep. But Verkabelt? What the fuck is Verkabelt? Verkabelt? Was it Verkabelt? And what the fuck is? I don't want to know what that image is. But yeah, it's USB. Mine is over the network. Okay. Anyways, I'm gonna end the stream. So have a nice night. Bye bye.